Hi, my name is Chad Williams, and today we're going to talk about multiple regression. Specifically, we're going to use the LM function. So what that means is we're going to be doing independent samples multiple regression. We need to start off by making data. So let's go reg underscore data equals, we're going to make a data frame, and then what we're going to do is we're going to create each column one by one. What we first need is our scores. And this design is going to have two different factors with each two different levels. So we're going to have four groups in total. So what we need is four different distributions of data. And we're going to concatenate our four distributions, and we're going to use the rnorm function to create them. And we're going to have 50 people per group. The first one's going to have a mean of 100 with a standard deviation of 20. And then the second one, same 50. And then a mean of, let's say, 140 with a standard deviation of 20. And then the third one will be 50, and let's say a mean of 110 with a standard deviation of 20. And then the last one will be, let's say, of 200 with a standard deviation of 20 as well. So if we look at all that, what we get is 200 scores, one for each person in our study. So we're going to have 200 people in total. The next thing we want to do is create our first factor, so factor 1. And we're going to use orthogonal coding here. So because we have two different levels, we're going to have one group identified as -1 and one group identified as +1. And I won't get into the details of what that means. So we're going to do something a little bit complicated, but what I'm going to do is I'm going to say repeat -1 100 times, then repeat +1 100 times. We're just going to concatenate these two things here. And so that should give us -1 100 times, then +1 100 times. And that's our factor 1. Factor 2, we're going to do a very similar thing, but we're going to do it with 50 each. So -1 for 50, and then +1 for 50. And that's just going to give us half the amount of data points, and we're going to repeat this whole thing twice. Once we look at the data frame, if this isn't clear why we're doing this, you'll see why when we're there. And now we have -1 50 times, +1 50, -1 50 again, and then +1 50 again. Finally, what we need is our subject IDs, which is going to be, because we have 200 people and they're independent, we're going to have 1 to 200. I see I missed a comma up here, so if we run this, we have our data frame here, where we have scores, factor 1, factor 2, and then subjects. So each group is identified by their combination of factor 1 and factor 2 identifiers. So -1, -1 is group 1. -1, +1 is group 2. +1, -1 is group 3. And then +1, +1 is group 4. Great. Now, the other thing we'll see is that these numbers are either numeric or interval, and our factors and our subject should not be. They should be factors, not numeric or interval scales. So we could change this by saying we want the second column, because that's our factor 1, to equal itself, but as a factor. If I go like this, we're going to do this for columns 2 to 4. So this one is 3, and this one is 4. So if I do that, what we see is our variables have changed to factors. Great. So now let's get to linear regression. We're going to use the native function LM from R, and we're going to say we want our reg results to equal LM, and we're going to add some stuff here. We're here for multiple regression, but let's look at a simple regression really quickly first. I have another video about that, but we can easily do that here as scores by, and that's a tilde sign there, by our, let's say, factor 1. And then we're going to say our data equals our reg data here. That's just our data frame name. Now what we can do is we can use the ANOVA function to actually check our results here. And that gives us our output, where we're saying the factor has a significant effect. But we're here for multiple regression, so let's do that. So So we're going to add our second factor, and we're going to do that with the actual addition symbol. Now if we do this, what we get is these results where we have a main effect of factor 1 and a main effect of factor 2. But what you'll notice is there's no interaction effect. Now we can add an interaction effect this way, where we add factor 1 times factor 2, and then if we run that, we get our interaction effect as well. Now a shortcut for that is if we don't want to write such long code, we can actually delete the two main effects from our model and just leave the factor interactions, and that will automatically add the main effect. So if I run this, we'll get the same results. Now finally, what we don't have here is type 3 sums of squared, which is important when we're talking about interaction effects. Now I haven't had the ability to get this ANOVA to do it, so what I'm going to actually do is use the ANOVA from the car package. And that is just like here. If you don't have it, don't forget to install it. And this is just a capital A ANOVA. And we could put then comma type equals 3. Now this is going to give us a type 3 sums of squared. And what we have is a main effect of factor 1, a main effect of factor 2, and then an interaction effect. We have our sums of squares, our degrees of freedom, our f values, and our p values for each of these. And I can even write out one of these as an example of how you report it. So let's talk about factor 1. So what we have is an f value of 1 degree of freedom, comma 196, and then that's going to equal our 13.091, comma p is equal to 0.0004, it looks like. And there is our main effect 1. And we could do that for the rest of them.